In OpenTunnel Designer 2023, a new option has been implemented for creating linear transition for the tunnel lining, but also for the reinforcement. The input for this new command is a start template and an end template for the tunnel, and the user needs to acknowledge that some inputs are required for correctly creating these new templates. So if we look on a tunnel template, something that is very simple, we'll look on the start template and we see here that we have the part numbers. Basically, we have divided the lining in 4 parts. Now, when we look on the end template, again, we can see that we have the same part numbers, but also we have the same category and the same material, so that we can create a successful transition for these elements. One thing to be noticed is that when we are creating the geometry that is defining the region that we are tagging, we need to have at least one line. So if we are defining here the shape as a collection of arcs, we may encounter issue when we are creating the transition. The same rules apply when we are defining the reinforcements. You can see here we have part 1 and part 2 with ID 1 and 2. And when we look on the start, again, we have the top one as 1 and the bottom one as 2. Placing this type of tunnel starts by selecting the start template and end template, and in here we can define the section length. Basically, using this value, we will create a transition on each 10 meters. So we select the start and end reference lines, and we can clearly see here how the tunnel lining has been lofted to accommodate for the transition. Now in the same time, we can have a look on how the reinforcement is lofted. We'll change here the templates. In this case, we can see that the lining is not lofting. This is just for this simple case. But if we place here shotcrete, on all sections, we can now clearly see how the shotcrete is lofted on the given length. We'll place now some forepoles. Let's say this has 12. Now we can see here that the forepoles are following the shape using the driving angle. But because we have defined the location of the circles of the forepoles on the start template and again on the end template, we can now manipulate also horizontal change in direction for the forepoles. So if we go to the end one, and let's say we are moving this somewhere around there, We'll save the changes. You may now observe that we have also a change in direction, not only given by the driving angle.